Hey Sanaya, this is Miss Falkenberg. I thought I'd give you an idea of what we're doing today. First of all, we're reviewing the multiple choice from Free Fall Part B. So if you have any questions on that, even if you want to identify some numbers from the multiple choice, I can give you a quick video on explaining how to think about it or how to go about it, some concepts that drive the principles. Second, I was going to do an overview of what we've done as far as walking through it. We had a constant velocity model that was with our buggies, position time graphs. We learned what do positive and negative slopes mean on a position time graph. What does a positive and negative intercept mean? And then we learned we know how to write equations for those scenarios. We discussed distance versus displacement, speed versus velocity. And then we got into some position time graphs that had some curves with it. And we talked about average velocity, meaning velocity, right? Displacement over time over a time period, a couple seconds, the whole trip, etc. Or instantaneous velocity, where the time interval was so small, right, that the velocity graph or velocity or the slope looked tangent to the curve. And then we got into a constant acceleration model, and we started with velocity time graphs, understanding one, we could get velocity and time from them. We could also get displacement by finding the area contained between the data and our axes, 0 point axes. We could see what was speeding up and slowing down from the velocity time graphs, and then learning that positive and negative acceleration didn't necessarily associate with speeding up and slowing down. It had to do, is it in line with the velocity, right? And therefore it would speed up, or does the acceleration oppose the velocity, which would slow it down? So then we got into free fall. I don't have that on here, where we had constant acceleration equations. A lot of people might just love those, right? So knowing the constant acceleration equations and how they work with either horizontal motion or vertical motion, okay? As far as resources, I've got some card sorts in Schoology. I have a conceptual review. I actually have a file on Schoology. I'll show you some AP Classroom and then Giancole practice problems. So let me show you Schoology. So again, the card sorts are there for you to look, and it's arranging cards like we did in class to see if we can match them up. I'll get a key up there by the end of the day today. This is the conceptual review, multiple choice. Some of them are probably familiar, but it's got the answer key basically on the PDF. These are solutions for your textbook. So if you're like, I just want more practice, I'm not sure what kind of reviewer you are. The solutions are weird, but you can find the answers to confirm if you got the right answers, okay? So they've got different units. We basically, I think, did 2.1 through 2.8, so you can go do some practice problems there. They have some good conceptual questions in front of the homework also. Aside from that, let me go to AP Classroom. I actually have this opened up to your view, right? I can do a student view, and what you'll see is one-dimensional practice questions, and so you can begin those and see how you do. Okay, a lot of these are going to be velocity time graphs and interpreting these velocity time graphs. Just kind of work through those questions if you want. That's a place that you can have review. So again, my philosophy on review is some students don't want to review, or they review very little, and some students want to review a ton. So if you're that type of student, I've got a lot of resources for you to keep things up to date, to overview the units, and so on. And again, feel free to use me during Bronco time this week, or even after school, just to give you some more confidence with the concepts. I hope that helps. I hope you are feeling okay, and I hope to see you soon. Bye.